Today, we're going to learn about the addition rule. All right, our learning targets for today is I will know how to determine whether two events are mutually exclusive. I will know how to use the addition rule to find out the probability of two events. Mutually exclusive. Two events, A and B, cannot occur at the same time. So if two events, these are Venn diagrams. Notice the first one on the left. The two event circles, A and B, do not overlap. So most people, here's a quick example. If you are a high school student attending Kellam, then you can't be a high school student attending Tallwood. You got to go to one school or the other. There's no overlap. But mutually, if you're not exclusive, let's say, what's the probability of you being a girl, and what's the probability of you attending Kellam High School? Well, there's lots of girls that attend Kellam High School, so you could be both. So you would be in that overlapped area of the two circles on the right-hand side. So here's their example. Decide if the events are mutually exclusive. You have a die, one die, even though they're showing two, which is silly, but you have one die. What's the probability of you rolling a 3? Event B is what's the probability of you rolling a 4? So when you roll a single die, you only get one event to occur, so you can't get both a 3 and a 4. That's not possible. So these are mutually exclusive. So you can either get a 3 or you can get a 4, but you can't get both at the same time. So that's mutually exclusive. All right? Here's another example. Decide whether they're mutually exclusive. What's the probability of you selecting a male student? What's the probability of selecting a student with the nursing major? Now, you can be a male nursing student, so those are not mutually exclusive. They could be both. All right, the addition rule. If you want to calculate the probability of A or B, and they're mutually not exclusive, there is overlap, you take the probability of getting A, add it to the probability of getting B, then you take and you subtract the probability of getting A and B. If they are mutually exclusive, like flipping a coin, getting a heads or a tail, you can't get both, you would just add the probability of A plus the probability of B. Now, you can extend this out for more than just two things. What's the probability of getting A or B or C or D? So like, what's the probability of you choosing a male? What's the probability of you choosing a teacher? What's the probability of them being at Kellam? What's the probability of them having gray hair? You would find the probability of each one of those and you would add them together, because all of them could happen at the same place. There could be a male teacher at Kellam with gray hair. All right, here's an example. You select a card from a standard deck, find the probability that it is a 4 or an ace. Well, when you draw one card, it's not going to be a 4 or can't be a hybrid 4 ace. It's going to be one or the other. So this is mutually exclusive. So you just add the two together. So 4 out of 52 plus 4 out of 52, you get 8 out of 52, and then you turn it into a decimal. So there's a 15.4% chance of getting a 4 or an ace. Now you roll a die, you find the probability of rolling a number less than 3. So on a die, a number less than 3 is 1 and 2. And rolling an odd number. All right, so when you roll a die, the odd numbers are 1, 3, 5. Now it's a good thing to write down the different events so you could see if there's overlap. In this case, they did a Venn diagram. They showed you that 1 is both odd and 1 is also less than 3. These are not mutually exclusive because they have the 1 in common. So you take what's the probability of getting a 1, 3, or 5. You'd add it to the probability of getting a 1 or a 2. Then you subtract the probability of getting a 1. So that's 2. 1 or 2 is 2 over 6. 1, 3, or 5 is 3 over 6. And a 1 out of the die is 1 out of 6. So you would do 2 plus 3 minus 1. You get 4 out of 6, or 0.666666. 66.7%. All right. Let's look at the frequency table. This is of sales and how many months that they obtain those type of sales. What's the probability of getting sales between 75,000 and 124,999,000? So you get 7 months for 75 to 99999, and 9 months for 100,000 to 124,999. These are mutually exclusive, so you would add those together and you would get your probability of sales between 75,000 and 124,999. All right. Here's another question. A blood bank catalogs the types of blood given by donors during the last 5 days. A donor is selected at random. Find the probability of being a donor has type O blood or type A blood. So O or A. So you have to ask yourself, is there any overlap? Can you have both O and A in you? The answer is no. It's one or the other. You can only have one type of blood. You can't have two. So these are mutually exclusive. So you would add up, there's 124 people out of 409. There's 164 people out of 409. You add those two up because they're mutually exclusive, and you get 85.1% chance of being O or A. Now, here's a different way of looking at it. Find the probability the donor has type B or he's an Rh negative. So, gotta ask you, can you have negative blood type and also be type B? Yes, right there in the middle. So they are not mutually exclusive. Negative is that row, type B is that column, so you would have to subtract out the thing they have in common. So it's going to be 45 out of 409 have type B, 65 out of 409 are negative, and 8 over 409 are both B and negative. So 45 over 409 plus 65 over 409 minus what they have in common, 8 over 409. So when they are not mutually exclusive, you have to subtract out the probability of the thing they have in common. All right, so here's a summary. Determine if the two events are mutually exclusive and use the addition rule to find the probability of the two events. So today's short, and hopefully you understood it, and this will help you do the classwork.